In the last article of the Cloud Native Leadership series, I proposed a solution architecture to integrate the API authentication capabilities with any cloud native applications through the CNAP platform. So, if you are an engineering leader who wants to have the API authentication capabilities into your cloud native applications without the need of any code changes or any heavy integrations or managing any NFR tool for this purpose, then this video is very useful for you. In this video, I'm going to start the implementation of the CNAP platform itself. And along with that, I'm taking the API authentication capability as the first use case. Let's start with a short recap. This is a typical cloud native stack which I have shared in one of my earlier articles. In the last video, we completed the implementation till the infrastructure foundation where we deployed the Kubernetes cluster on top of the physical infrastructure. On top of that, you can deploy your cloud native applications, but for them to function, you need certain non functional requirements integrated with it. The platform services provide you these non-functional requirement capabilities, but in the absence of a platform to manage these services, you will be having the platform service managed in a very ad hoc way, in a sense that you need to have your developers do the NFR integrations. For that, they need to have custom coding done with their business logic. They can have the integrations with the NFR tools which are customized for their applications and microservices, as well as if you have multiple teams working on different applications and microservices, there is a possibility of the effort being duplicated because they can be doing the same kind of integration with similar tools for their individual applications and microservices. Now, with the CNAP platform in the picture, what we can do is we can have all these non functional requirements and the associated tools integrated and inbuilt into the CNAP platform itself in a way that the CNAP is providing you with the capabilities of all these tools. All you need to do is bring up your cloud native application, and with a very simple declarative YAML, you can just tell the CNAP that what are the capabilities that you need from the platform, and you will be getting it without any heavy integrations or any custom coding required in your application. So basically, no code change is required in your application. You just need to have a very simple, very basic schema-based, YAML-based integration with the CNAP platform. Now, for the current implementation, the current integration for the API authentication part, what I'm doing is, along with the CNAP's development, I am also integrating two NFR tools, one for API Gateway, one for IAM solution. For API Gateway, I'm using Kong with its Ingress controller, and for IAM, I'm using Keycloak. So, along with the CNAP's development, I am going to do the integrations of these two tools. Plus, I will be writing a sample application and also demonstrating how, with the CNAP platform, with these two tools integrated to it, if you onboard your application, then how you can use the API authentication with very simple integration steps. So for that, this is the agenda for the development and integration. This is the roadmap. So the first thing that I'm going to do is I'm going to create the CNAP project directory structure. Once it is done, then I will be creating the Helm chart for the CNAP and the packaging script so that I can have the capability of packaging the Helm chart, which is then used for deploying the CNAP on Kubernetes. Once it is done, then the first integration that I will do is I will integrate the Kong-Ingress-Controller, which I will be saying KIC from now onwards, into CNAP so that it gets deployed as a dependent chart with CNAP. Similar thing I'm going to do with Keycloak. Once it is done, then I will be doing the test application development, and we will be doing some basic testing with that. Initially, it will be all manual, and then as we go along, it will be automated down the way. And at the end of this whole roadmap, everything will be automated, and in the final integration testing, we'll be seeing end to end implementation of this the CNAP platform with these two tools integrated to it. So after that, since Kong provides a very robust plugin development capability, I am going to develop one OIDC plugin which is going to talk to Keycloak for token management, like getting the token and validating the token, and based upon that, allowing the request from the client to send to the upstream service or not. Then I'm going to configure the key clock for all the token related configurations. Once it is done, I'm going to define a CRD with the name applications. This is the YAML schema that I'm talking about. Once it is done, then the respective operator is also required. So I'm going to develop that as well. Once the operator is developed, then I'm going to integrate this applications CR with the test application in a way that I'm going to create one YAML and plug in that YAML with the test application's Helm chart. And once it is deployed, then the operator will get executed and it will do its related operations. And then in the final integration testing, we are going to see that how, with a simple change in the configuration, that is just to set true or false for the API authentication capability in the YAML, any application which is deployed on CNAP can enable or disable this NFR capability. And similar to that, for any further NFR integrations, you can use the same YAML for enabling or disabling the required NFR capability as per your application's requirement. All right, so let us start the development now. The first activity that we need to do is to create a CNAP project directory structure. So I'll be using Visual Studio Code as the editor for me, and the whole code is going to be residing on this virtual machine, this CNAP VM on which we have created the Kubernetes cluster before. So I've created a project directory called project CNAP. In that, let me create few directories here. So for source, let me create SRC. For deployment related artifacts, I'm creating deployment. And for sorted nodes, let me create a readme.md. .md for CNAP. I'll be keeping it blank for now. Now, inside the deployment directory, I'll be creating a directory called Helm Chart for the CNAP Helm chart. Let me create a directory here. CD Helm, oh sorry, mkdir. And then inside that, I'm going to create a Helm chart for CNAP. Okay. Okay, so it created a directory called CNAP itself. So let me do one thing. In so ls CNAP. So whatever is there in CNAP, I will be removing everything to this Helm chart directory, and then remove this CNAP directory. Okay. So with this, the CNAP project directory's basic skeleton structure is created, and I have initiated a helm chart for CNAP as well. Now for the packaging scripts, so normally I tend to create a script or a set of scripts to create the packaging of the complete project artifacts. So for now, I'm just going to create a blank directory called scripts for that, and inside that I'm going to create a script. Normally I call it packaging.sh. So when we reach to the point where we need to create a package, then I will initiate the script and I'll keep it here. So with this, at least our first two steps are complete. Next, I'm going to start the integration of the Kong-Ingress-Controller's Helm chart within the CNAP's Helm chart so that it becomes its dependent chart. And similarly, after that, I'm going to do the same thing for Keycloak. So let us start with the next step. To add Kong Ingress Controller and Keycloak as dependent charts, what I've done is I have created a directory called dependent charts inside the deployment directory. Inside that, I have kept these two charts extracted. These I have already downloaded from the internet. So with that, these two are placed in this dependent charts directory, and then I'll add these two as dependent charts into the chart.yaml of CNAP. So this is the CNAP's chart.yaml. I will add dependencies. Then the first is Kong-Ingress-Controller. Version is 0.21.0, and repository, since it is local, so it is file colon slash uh, dependent chart slash Kong Ingress Controller, and for Keycloak as well. Keycloak. The version is 1303. 1303. Okay. So once this is added, and if I execute Helm package, it will read the locations of these two charts from this location, and then it will package these two as dependent charts inside the CNAP subchart. So the next thing that I'm going to do is to create a packaging script, and inside that I will be doing all these processes. So since there's a utility script, I'm not going to actually write the code. I'm going to generate that through some AI tool. And once that is done, then I'll place it into the scripts directory. So let me do that, and then I will resume. Okay, so I've made the script. I'm currently using Visual Studio Code for the development. So if you can see, I have opened this project CNAP in that, and inside that, I have a scripts directory, and there the packages.sh. So this is something which I have generated through an AI tool, and I'll just run through the script. So basically, this part is to create some variables to point out to certain directories. So one is the script directory, then the deployment directory. And so what I've done is with this script, when it executes, it creates a target directory, and inside that it creates the Helm chart package as well as the Helm chart directory. So the name of the Helm chart directory is CNAP, and the Helm chart source from where it will pick the parent chart is Helm chart, and all the dependents charts from the dependent chart directory. Now, from the now, furthermore, so I have also introduced one directory called CRDs inside the Helm charts, because I'm going to create a CRD for the applications which anyone wants to deploy on top of this platform. And from there, they are going to use the YAML based schema through which they can enable or disable the functionalities they want with their application. So it checks whether the Helm executable is available or not. Then it deletes the target directory if it exists, and then it recreates that. And after that, it copies the parent Helm chart from the Helm chart source, and then it creates this CRDs directory. And then uh, um, if the CRDs directory is not available, then it does not copy that. Otherwise, it will copy everything from CRD directory. So I'm basically trying to create a convention here. So what I have done is any CRD file should start with the name CRD hyphen, and it should be of the YAML extension. So it will be copying everything from this CRD directory to the target CRDs directory. And then finally, it is going to execute the helm package command. Now, since the parent helm charts.yaml has the details of the dependent charts and the location of their helm charts, so helm package will read it from there, and it will automatically copy the dependent helm charts from there, and it will create the charts directory, and it will copy the tars of all those dependent charts into that, and then finally it will tar the CNAP helm chart. Then there is some cleanup, and that's it. So let me do one thing. I'll execute this command, this script once. So package.sh. Now it has created this target directory, and if you can see that all these directories and files are copied from the Helm chart directory. And right now the charts directory is empty because currently it is executing the Helm package. Once it is done, then it will contain the tar of both the dependent packages. Okay, so now this is complete, and you can see that this charts directory has the Keycloak and Kong-Ingress-Controller tar files inside it. Let me, okay, so it has these, and there is also one more thing. I have also added the values.yaml. So currently it has configurations for the dependent chart. So Kong-Ingress-Controller, there isn't any specific configuration that I need to do right now. So I've just kept that gateway deployment as blank. And for Keycloak, there are certain things. So one problem with Keycloak that I faced was very recently the Keycloak's secure images are under a payment gate now. So I am forced to use the Bitnami legacy image for Keycloak. Though it is sufficient enough for our purpose, but for any commercial purpose, if we need to use the Keycloak, then I am afraid that the license need to be purchased for any latest secure images. And there are some extra variables which I have put. Uh, the host name, URL proxy, and some of these which I got to know that these are required environment variables. Then some authentication related things, and Postgres is enabled because all the configurations which are done in Keycloak will be saved into the Postgres. And to enable Postgres, we need to first create a PV, which I've already created in this cluster. And for anyone who wants to use Postgres, they need to basically create this PV so that the PVC can be bound to it, and then the ports on which I want these to run. So let me do one thing. So in the target directory, it is already there. So I'll do one thing. I'll go to the CNAP and let me do Helm ls. So no Helm chart is installed as of now. So let me also do k get PO. So one thing is that I have set the CNAP as the default namespace. So if I execute Kubernetes commands, the kubectl commands without any namespace, it is by default going to use CNAP as the namespace. So right now you can see that there is no pod which is specific to the CNAP is deployed. This is my curl pod. This is something which I have used for executing the curl commands for doing some debugging. So this is the only thing which is running. So what I'm going to do right now is I'm going to install the CNAP Helm chart. Helm install CNAP in the current one. Okay, it is giving me some error. Let me see. CNAP templates. Okay, so inside the templates, there are all these files and directories which are created, but these are something which I don't need as of now. So what I'm going to do is I'm just going to delete them for now. So tests. Okay. Okay, so I've deleted this. So I'll again execute the package command, the package script, so that it can create the new CNAP package with all the files deleted inside the templates directory. So I've deleted it because right now there is no specific deployment which is required for CNAP per se. But yes, whatever are the dependent charts, we need to deploy them as part of the deployment of CNAP. So let me go back, target CNAP templates. Right, okay, so this is blank now. So let me again execute Helm install CNAP. Okay, so the CNAP has installed Helm ls-q. So the Helm chart is installed. Let me check the list of pods. Get PO. Okay, so controller and gateway, these are the pods for Kong-Ingress-Controller. The controller is for the Kong-Ingress-Controller and gateway is for the Kong API gateway. So this is the Keycloak stateful set. It is created, and Postgres is also created as part of Keycloak. So right now they are getting initiated. So let us also check the PV and PVC. PVC. So PV and PVC are also bound. So I am actually using some PV which I have created some time back. So I'm repurposing that. The Keycloak is going to take some time to initiate. It always does actually. just put a watch on that. Okay, so now all the pods are in running condition, controller, gateway, Keycloak, and the PostgreSQL for that as well. So with that, both of the integrations of these two tools are done within the CNAP. So this is the basic integration that we have done. Now we are going to do the configuration for these, and as well as we are going to create the test application which will be exposing its REST API so that we can do the testing with that. And once it is set up, then we are going to do the configuration for the token-based API authentication. Okay, so let's start with the next step in our roadmap. So we have completed the first 4 steps of the roadmap. We have created the directory structure for the project. We have created the Helm chart for CNAP and the packaging script as well as we have done the integration of KIC and Keycloak with CNAP. So with these 4 steps, if we deploy the Helm chart of CNAP, the KIC and Keycloak get deployed. Their required pods are up and running. The next step is to create the test application for development. So this is basically a test application which will be exposing a few REST APIs. So I'm going to create a Python-based application for that, and I'll be using the Flask framework for it. And then I'm going to create the Docker image for that, because this application itself will be running as a pod in the Kubernetes cluster, so that it can connect with the the NFR services like Kong and Keycloak with the Kubernetes' own internal DNS. So let us start with the test application development. Okay, so in the project structure, I have created a directory called tests, and inside that there is a directory called app. This is a test application which I'm going to use for testing the REST APIs. So this is a very basic Flask-based application. So if you see the code, it's not a very big application. So what I'm doing is I have exposed two endpoints. One is slash, which is the home page, and it returns this simple string, welcome to the Helm demo app. And another one is slash API slash status, which is a get method. And all it is doing is it is sending the status and version as a string. So this is the very basic application which I have created. And with that, I have also created the Docker file. So this Docker file is using the Python 3.9 Slim as the base image. And after that, I'm copying the slash app and then installing the Flask package onto the image, and then copying the Python file for the application, exposing it on the 5000 port, and giving the command that needs to be executed when the image gets containerized and the container is running. And along with that, a very few basic Helm chart templates. One is for deployment, then for exposing it through a service, the chart and values. And in this values, I'm giving very basic details like number of replicas that I need to create, the image. So so basically this is the image name which is going to get created when Docker build is run, and then its version, then the service. It is a node port service with the target port as this, and node port as 30763, which will be exposed through this service. So let me do one thing. I will be creating the Docker image of this particular application, and then I will package it into the Helm chart, and then I will deploy the Helm chart onto this cluster, and then we can see how the test application replies back when we call its APIs. So as these APIs are going to be called directly first, they will be responding directly. I will be calling this node port, and once this is done, then we are going to expose these REST APIs through the Kong gateway by creating the ingress rules for this particular application. And after that, the request will basically be passed to the gateway and ingress controller of Kong. So let us get bring up this application first. I'm going to use Docker to create the Docker image. So to do that, let me execute the command sudo docker build -t my user slash helm -api dot. So since we are using containerd as the container engine, so once this image is created, then we need to push that image for containerd also to use. To do that, I'm going to use the CLI command. So first of all, we need to save it, this Docker image. So to do that, let me do it. First of all, sudo Docker images. So we have this image. Okay. So sudo Docker save this -o helm -api.tar. Okay, so once this is saved, then I'm going to import it to containerd. Right, so it will be sudo ptr-n equal to ktest.io import I guess images. Okay. Okay, so this is imported. Now I think we are good to go to give it a try for the app Helm chart to be deployed. So let us see. First of all, let me remove this Helm API.tar, and where is the chart? Okay, I'll go to the chart. Let me execute the command Helm import. Sorry, Helm install. Let us name it as simple-api dot. Okay, Helm ls-q. All right, so simple API and CNAP are both installed. Let me check the list of pods. K-get-po. Okay, wonderful. So my sample application is also installed. Now let me set up the Postman tool so that we can call the APIs which are exposed by this test application. So in this current view, I have this Postman installed, and it will be calling the simple API applications APIs. And these are the two terminals for the CNAP VM which I have opened. Now let me show you the service on which the simple API application is listening on. So okay, get svc grep simple-api. So it is listening on 30763 port. Now in the Postman, I'm using the same port, but I'm using the localhost because I'm using a virtual machine, and I have port forwarded this port, so I can use the localhost for accessing this particular port on the VM. And if I see the list of pods, I have two pods running. So basically, these are two replicas of the simple API. So for the load balancing purpose, they will alternate on the request processing. So let me run the logs for both. Okay, logs -f-tail equal to 0. Okay, logs 0. All right. So let me send the request now. Okay, so the first replica has answered and we have got the response back. Let me hit it again. Okay, again the same replica has answered. Let me hit it again. Okay, so now this time this replica has answered. Let me call the other API status. Okay, I'm getting the answer as expected. And both the replicas are doing the alternate response for the load balancing purpose. Okay, so we have completed the implementation of our test application. Now let us start with the next item in our roadmap. So we have completed the development of the test application. Now let us move to the next item in the roadmap. Now there is a slight change in the roadmap. So initially I was about to create the OIDC plugin for Kong, but without the Keycloak configuration, we will not be able to test it. So I have moved this Keycloak provisioning before OIDC plugin. So let us start with the provisioning of Keycloak. The Keycloak is listening on the port 30443. Its node port is open on this, and it is on it is HTTPS endpoint, and this is the URL of the Keycloak. So we are going to move into the administrative console. The past username and password is the same which we have given in the configuration during the CNAP deployment. So this is something which you will find in values.yaml of CNAP Helm chart. Now the first thing that we need to do is to create the realm. Um, so let us name it as CNAP, enable it. Okay, so the realm is created and we have shifted to the CNAP realm. The next thing we are going to create is a user. So username is something we can name it as API user. First name, we'll say test, last name user. Let us create it. After this, let us set up a password for it. So we'll say password is password and let us make it as permanent. Okay, so the user is created. The next is to create a client for this particular application of which we are going to access the APIs of. So let us name it as API client. So test user client. Okay, save. So this is created. Now let us create the root URL. So what I'm going to do is instead of using 127001, I'm going to create a host name for our project. So let me name it as api.example.com colon 30443. So there's the root URL and the home URL is something. We'll use a wildcard star for everything after this. Valid redirect URL. So logout is also this and web origins is this. Okay, so we'll save it. All right, so we have the client created, API client, and we have the URL created, and let us also see the credentials for this client. So client user API user credentials. We have set the credentials for this. Let me go to the API client. Let me do one thing. Since we need to have the credentials, we can enable the client authentication, save it. And after that, we will get the client secret. So this is something that we are going to use the client name, client secret, and as well as the URL to access Keycloak and to fetch the access token. So once that is done, once we are able to fetch the access token from Keycloak, then we are going to create the OIDC plugin from for Kong. And whenever we are going to send a request to Kong, then with that OIDC plugin, it will execute the same operation that is fetch the access token. And if the access token is valid, then it will forward the request to the upstream. So let us first try to execute the API of Keycloak to access the token, to get the access token manually through Postman. Okay, so from the Postman, we need to create a post request. So this is the URL of Keycloak, and we can either use the 127001 or the host name that we have created. After that, we need to put /auth and after that /realm and then the realm name that we have created. So we created CNAP. Then after that /protocol /OpenID connect /token. So this is a very well-known endpoint. So we are going to use it, and in the body we need to put client ID, and in client ID the ID is API client. Grant username is API user. password is password. Okay, so let me go and copy the credential here. Client credential I'm going to put here. Run type is password, and let me hit this URL. Okay, so with this we have received the access token. Now using this access token, we can uh, we can access the simple test APIs once they are configured in the Kong gateway. Okay, so now this is done. The Keycloak provisioning is done. Now the next item in our agenda is to configure the to create the OIDC plugin for Kong. So let us do that. Okay, so the next agenda item for us is to create the OIDC plugin for Kong. So this plugin is actually going to validate the access token that we get when we call this particular URL. So just to show you how it does. So if we call this API and get this access token, so we need to make sure that this particular token is valid, because it has a short lifespan. So whenever some client application is calling the API, first of all, it needs to gather this access token by calling this API, and then it needs to send that token, send the API call along with this access token. When this request reaches to Kong, Kong needs to call the Keycloak to validate the access token, and if it is active, then only it will send the request to the upstream service. So in order to do this, Keycloak provides us a URL. So this is basically the URL to call to check whether that particular access token is active or not. So it requires client ID, client secret, as well as token. So we are just going to paste the token that we just fetched, and in the response you see that the active is currently true. So that means this is currently an active token. So in case this token has some problem, or say if we have some older token, so to simulate it, I'm just adding a queue in the front. So if I send it, it will say false. So it will always respond 200 okay. Keycloak will always respond 200 okay, but it will tell whether that particular token is active or not. So if it is active, if it is correct token, and if it is active, then you will get a response something like this, where you are going to see that active is true. Otherwise, you are going to get a response 200 okay only, but in active it will be false. So this particular URL and calling of this URL is something that we are going to code in the OIDC plugin. And then if it is successful, then only Kong will send the request to further upstream service inside the cluster. So to do that, um, I have already created the code. So inside the SRC directory, so since this is a custom implementation for CNAP platform, I have written the code inside the source directory, which was earlier blank. So inside that, I've created a directory called plugins, and then inside that Kong-Ingress-Controller, and inside that the directory which I've created contains the plugin code. So the convention that I'm following is that the directory name should be the same as the plugin name. And in Kong, it actually provides us the capability to extend the capabilities of the gateway by adding custom plugins to it, and we need to write that in Lua. So it provides us a kind of a framework to write the plugin. So it expects two files. One is handler.lua, another one is schema.lua. So if you go into schema.lua, uh, so these are some basic things that we need to add, at least in the schema. First of all is the plugin name. Secondly, the fields that we need to pass as variables when the plugin is called. So as we saw that inside that Postman request, we need to pass the client ID secret, as well as this is the token validation URL that we need to call from the OIDC plugin. So these three things are something that we are going to call, and with that, the handler.lua is the actual implementation of the plugin. So I'll just go through this code once. So these are some basic imports. One is to create the HTTP client to send the request and fetch the response. Another one is for the JSON processing. The next thing is basically to define the priority of calling this plugin for Kong. So Kong has a way of calling the plugins based upon the priority for that particular plugin. So you can define the priority. So Kong has a list of priorities which are already pre-used. So they are available into the documentation. I will add the documentation in the description of this video. So for now, I have used 1000 as priority for calling this plugin. Secondly, when a request reaches Kong, it has a certain lifecycle steps to process that request. And based upon that lifecycle step, it has certain predefined functions so that when a request reaches to that particular step, it can call the function from the plugin. So Kong, when you pass the plugin to Kong, it basically creates a table for all the functions that it can call for that particular lifecycle step. So for now, the access is the function which Kong calls when the request reaches to the gateway before it starts its processing. So for now, what we have done is we have called this, we have created this function. So in that, the conf is basically these three fields which are in schema. So conf basically contains that. Now the code is something like, first of all, it checks for the HTTP authorization header in the request. So when the request is sent by a client to the Kong gateway, in that request, it needs to add the authorization header, and inside that, it needs to add the token which it has fetched through the token API. So if the authorization header itself is not present, then the request is cannot be processed any further. So it will be exited with error. If it is there, then we are going to create an HTTP client, and then we are going to call this request URI function, which is going to call this validation URL. And the method is post body. In the body, we are going to call, we are going to send the client ID, client secret, as well as the token which we have fetched from the request. And the content type is this. Now, after that, if there is no response, then obviously we are going to say error. If we get the request, if we get the response, but if it is not 200 okay, then also we need to send an error. And if we get the response, then first of all we are going to decode the body, and inside that we are going to check whether it is active or not. If it is not active, then we so basically it will say that the active is available or not, and if it is not available, then we are going to say error. And if active is true, then it is okay. So based upon that, we are going to set the X user ID and X username, and then we are going to say that the token is successfully validated, and we are going to close the HTTP client connection for which we have opened as well. So these two files are created for the plugin. Now to send them to Kong, what we need to do is we need to create a config map, and in that config map we need to put these two files. And to enable the plugin, we need to create a Kong plugin resource as well. So the config map is used to install the plugin, and Kong plugin resource is used to enable the plugin. So to do that, I have created these two templates. Inside that, I'm using a variable called var plugin name. This is something which is going to replace the actual plugin name in both config map plugin as well as in Kong plugin. So if you have more than one plugins for Kong, then you can add a similar directory like OIDC inside this Kong-Ingress-Controller directory. And I have extended the packaging script so that it picks up that directories from this Kong-Ingress-Controller directory and these templates, and then it creates a config map and Kong plugin for each of the plugin which you define in this particular order. So to do that, I have extended the package script as well as added another script for generating the plugins code. In the package script, this is a section which is added. Basically, these are some variables. One is for the script, another one is for the CNAP root, and then the plugin source directory and the destination where we need to put the generated YAML files. Then we call these the script with the source and destination variables. Then in this particular code, generate Kong plugins script. Initially, there is some basic utility code and some options to create to call these scripts with various switches. Like if you want to do a dry run for help, all these functionalities are there in the script. And then after that, there are few variables like where is the template directory, where is inside the template directory, where is the Kong plugin template, where is the config map template. Then after some validations, we are going to call this code, like for each particular directory in the Kong dir, which is the plugins Kong Ingress-Controller. We are going to first check whether the handler.lua and schema.lua files are available or not. If they are available, then we are going to create the outgoing, or basically the Kong plugin and the config map that we are going to generate. And once that is done, then we are going to replace this variable with the actual plugin name and put it into the outgoing, the generated Kong and the config map. Similarly, we are going to do the same thing for config map. And once these two files are generated, finally, we are going to create a data section inside the config map and put the code of handler.lua and schema.lua inside it. And then these two files are kept inside the target directory. So let me do one thing. I'll just execute this script once. So scripts. So before that, let me do one thing. I'll delete the target directory, delete, and then package. Okay, so it is saying that it has processed one plugin OIDC, and let me see inside the target directory inside CNAP. So in the templates directory, now we have two files. One is the config map, so this is for the OIDC, and another one is for the config plugin for OIDC. So these two files are created. So when we deploy the Helm chart of CNAP now, these two files will basically be deployed and their related resources will be created in the Kubernetes cluster. So now we need to also pass the variables that is the client ID, client secret, as well as the validation URL, because for each and every cluster they could be different. So to do that, what we have done is inside the values.yaml for Helm chart, for the CNAP Helm chart, I have introduced this section, which is so basically the convention for this is inside the CNAP, you need to put the name of um, uh, the the gateway Kong-Ingress-Controller, and inside that plugins, and then the plugin name, which particular plugin name you want to put the config for. So OIDC is the plugin name. Then in the config section, we have client ID, client secret, as well as the token validation URL. So once you do that, and if you see inside the Kong plugin OIDC, we are picking up these configurations for the usage of this particular resource, and using these values, the Kong plugin, or the Kong plugin will get created. So so in this way, we are going to create the plugin, the OIDC plugin for Kong. And let me do one thing. Then let me now execute this particular new Helm chart. So Helm ls-q. We already have CNAP, so let me check get clear get cm. So we do not have a config map for now, and if I Kong plugin, we do not have a Kong plugin as of now. So let me go do a target CNAP ls So we have this Helm upgrade CNAP dot. Okay, so the upgrade is successful. Let us check the config map. Okay, it is created. Okay, get Kong plugin. This is also created. One more thing I forgot to mention is that this token validation API that I'm calling, it is using the Kubernetes internal uh, cluster DNS, and it is an HTTPS URL. So to enable it, what we need to do is we need to get secret. If you see, we have a Keycloak secret with us. So we need to mount this particular secret into the Kong as well so that it can use it. So to do that, we need to basically do these configurations. So first of all, we need to mount that secret, and then we need to access that secret using this environment variable. So once this is done, then your this API, when Keycloak will call this API, and then this API call should be successful. Okay, so with this, the OIDC plugin development is complete. It is installed and it is enabled as well. So to check that, what we can do is we can get PO. We can do a describe for this particular pod. So K describe PO, and in this you need to check the variables for Kong. Okay, so if you see this Kong plugins environment variable, so along with bundled, we also have the OIDC plugin installed in Kong, and with that Kong plugin resource installed, now what we can do is we can create an ingress resource for the sample application for its REST APIs, and we can add the Kong plugin resource name inside that as an annotation, and then when the client calls the API of the this particular test application along with the authorization header having the token, so that particular token will be validated by this plugin by connecting to Keycloak, and if a token is valid, then that request will be sent to the upstream service, otherwise it will be rejected. So let us start with the next item in our agenda roadmap. Okay, so before we move to our next item in the roadmap, let us do some manual testing with the OIDC plugin. So we have already installed that in Kong, and it is already enabled. So for now, if we execute this API of the test application, we get the response. But if we call it through Kong, so Kong is currently running on 30723 port in the HTTPS. So right now Kong is giving us the response, no root matched with those values. So right now there is no root in Kong for this particular application. So what we need to do is we need to install one ingress tool for this application. And once it is done, then when we are sending the request to the application through Kong, then it should work. So to do that, what we can do is we can add one ingress.yaml. So this is something which I have written. The important parts here is are these two. One is the ingress class. Another one is the paths and the host on which for which we need to create this ingress rule. So these values are configured through the values.yaml of this chart. So the class name is Kong, host is api.example.com, and we are basically sending slash as path to enable all the paths after that. So let us do the upgrade. Helm upgrade simple API dot. Okay, so this is upgraded. Now let us retry calling it. Let us wait for a minute. Okay, let me recheck. Okay, get svc grep proxy 30723 is correct. So ingress we have created. Let me try to get the ingress. Get ingress. Oh, it is not created yet. So it is not created. So I think I did not put it into the templates directory. So let me retry that. Okay, so here it is. Now let us try. Okay, so now we are getting the response from the through Kong. So let us try the other API. Okay, this is also working. And to enable the plugin, what we need to do is we need to add an annotation in the ingress. So annotations, let me add kongHQ.com/plugins. The plugin name is Kong plugin-OIDC. So this is the plugin that we created, and now we do the Helm upgrade again. Okay, so there is some, okay, so annotation should be inside the metadata. Okay, now we retry. Okay, so this is successful. Now let us retry this. Okay, now if you can see, after the plugin is enabled, it is giving me the 401 error. The reason could be, okay, so the authorization header we have not passed yet. So in this authorization header, we need to send the access token. So let me enable it. I think this is something which is an older token, so I'm not sure whether it is going to work. Okay, so it is not working yet. So let us regenerate the token again. So this is the token API. Let us copy this token and paste it here. So if it is active, then we should get the response. Okay, super. So we are getting the response now with the authorization header with the correct token. Now let me try the other API. Okay, so we are getting the response for that. Now again, we disable it and we are getting the 401 again. And if we enable, we get the response. Okay, so with this, it is established that the plugin is installed properly and it is functioning as expected. If we are passing the correct token, then it is giving us the response. If we are passing wrong token or we are not passing the authorization header, it is not allowing us to send the request to the upstream service. So this is working manually. Now the same thing we need to enable it in CNAP, so that any application, if they want to deploy their application on top of CNAP, they should be able to use this functionality through CNAP. So to do that, what I'm going to do is I'm going to create a custom resource for the application kind. And in that custom resource schema, I'm going to put the parameters to enable or disable the API authentication through a Boolean flag. So if any business application is deployed on CNAP and it is also creating the custom resource for the application kind which is consumed by CNAP, and they want to use the API authentication, all they need to do is to enable it in that particular YAML. And then I'm going to also write an operator, a Kubernetes operator, which is going to consume that YAML. And based upon the configuration that you have passed in the YAML, it is going to enable or disable the functionalities as per that. So let us start with that. So the next agenda item for us is to create an application's CRD, which is a Kubernetes custom resource definition, and an example for that. So before I go to the schema definition, I'm going to first explain it through an example. So this is basically a YAML file, which will be added to the Helm chart of any business application. And once this is deployed, this is going to be consumed by the application operator to enable or disable any non-functional requirements which are defined as per that YAML file which is deployed along with the application. So I'm going to open the example first. So this is an example YAML, and so it has these four sections: API version and kind are something which Kubernetes expects by default. API version is something that is defined inside the schema. So the first part is the group, and second is the version. Kind is the application. It is also defined in the schema. In the metadata, it has the name and the namespace. And in the specs section, it has three subsections to it. The first is the integrations part. So in the integrations part, you need to explain that which of the non-functional tools you want to use as part of your applications. So right now, the current support is for the gateway. So for example, if you have uh, a gateway which is already available into your enterprise, you can develop an integration for that and you can use it here. And if you want to use something which comes as bundled along with CNAP, so you can basically name it here, and according to that, the operator will behave. Along with the gateway, it also has the add-on section in which you can define any plugins or any add-ons which are understood by that particular gateway. And those add-ons, you also need to explain which of the Kubernetes resource you want to apply those add-ons on. So, for example, in the current example, the plug in the plugin section, the resource name is Ingress, and the add-on name is Kong plugin OIDC, which we have created in our earlier section. So what actually this is doing is it is going to apply this add-on resource to all the ingresses inside your application. So this is something you should use when you know that this kind of add-on is something you want to add into all of the resources of your application for this particular type. Otherwise, you can keep it as commented. So this is the integrations part. So as we add more NFR capabilities, this section will get extended. And the next section is the global part. This is basically for the global configurations. So the first part is the base domain. So this is a URL which will be used by all of your REST APIs. So if you have a single base domain which will be used by all of your REST APIs, you can just put that here. If you have some different base domain for some of your REST APIs, then that is also possible into your API per API section that we are going to see after some time. So base domain is there. Then you have the environment prefix. Environment prefix is something that you can define for your environments. For example, if you're developing your application development environment and it has a different cluster, then you need to access the URLs for from that particular environment, and when you move to the next environment, you have some different kind of a cluster. So there the URLs will be different. So instead of managing all these URLs separately, what you can do is you can define a prefix for each of your environment, and when you apply this YAML for your each of your environment, a separate ingress will get created with that particular prefix added to the URL of your host, so that you do not have to manage all these things manually. The next is the authentication part. In the authentication part, as of now, we are defining two methods. One is based on basic auth, and another one is API token. So the API token is something that we have implemented just now. So the enabled is basically to enable or disable the API token as a whole. And then this is basically the definition of the specific add-on resource that you want to add into your ingress for this particular for enabling or disabling the API token. And single sign-on is something which is kept here as just a placeholder for now. So this is the global section. Then in the next is the component section. So this is a microservice wise section. For each microservice, you need to basically define one particular subsection for that. And inside the subsection, you need to define what are the APIs that you are exposing through your microservice. So that is done through the routes. So if I open this, so this is the name is the home page, path is slash, and if you see this particular variable, this through this variable you can enable or disable your API authentication. So if you mark here as false and do a Helm upgrade for your application, the API authentication for this particular path will be disabled. If you mark it as true, then it will be enabled. Similar to that, there is another API, the status API. And here, as you can see, the base domain is different from what we have defined in the global. So for this particular API path, api.example.com will be used as a host name inside its ingress. So the path is defined, and again, things like what is the type of the method, which Kubernetes service it is mapping to, and which is the port of the service and which is the port of your container. And then the auth enabled and HTTPS enabled and whitelisting is currently not supported, but it is kept here for placeholders to add these capabilities later on. So this is the example for a YAML which any application can create for them when they are onboarding their application on the CNAP platform. And as you saw that with just a single enable disable of a variable, you can enable or disable all these kind of an NFR capabilities as they are as we add the support for them. So with this application, this is the CRD which I have created. So the CRD, so these are the basic Kubernetes API version and kind which is expected metadata, the name of the CRD, then the group, and the name of your the kind of your CRD, plural, singular, short names. It is namespace scoped, so you need to specify a namespace when you are creating this custom resource. Then the version, and after that the schema is defined for that complete example that I have just showed you. So you can go through the schema and you can basically map all these objects and arrays with that example that I have shown you. So all these things are available in GitHub. So you can basically map the example with the CRD and understand that and extend as per your requirement. So this is the CRD in an example that I have created. So now this is created. So let us create the applications operator, the Kubernetes operator, which will operate on all these parameters. So right now I'm going to create an operator which is going to operate on the API authentication parameter. And that particular operator will be something which is going to be extendable, so that if you have any more number of gateways, you can just extend the base class for that particular gateway, and then you can do your implementation. So this is something which I am going to employ an AI tool for generating the code. And once that code is generated, then we are going to test that code with this particular example with the test application that we have created within this project. So let us start with the development of that operator. So I have generated the application operator code through an AI tool. I used few short prompting in which I passed the schema and example into it, and along with that the prompts to create a code using KOPF framework, and to create a code which can be extended to support different kind of integrations. And for now, specifically, since our integration part contains the gateway, the code which is generated is currently supporting the gateway extensions in a way that for any additional gateway we can basically extend a base class, and we can write our implementation to support any number of gateways within CNAP. So let me pull the code. Okay, so this is a custom implementation, so it is going inside the source directory because this is specifically for CNAP. Inside the operators directory, this directory I've created operators, then inside that there is the applications directory which contains the operator code. And inside the SRC, the operator applications.py is the file which contains the code which is understood by the KOPF framework. So KOPF provides us annotations to support different states of a resource. So for our application resource, this particular function or a method is going to be called when the resource is either created, updated, or resumed. So inside this particular code, we can see that first of all, it is extracting the integrations part from the specification. So in this method, the spec part, name, namespace are taken from the YAML of the custom resource, and then the logger and extra variables, if any. So from the spec part is taking the integrations part and the gateway part, and from the gateway part it is taking the gateway name, and then it is checking if the gateway name is available. Then it is calling the gateway underscore managers get underscore handler method. So this gateway underscore manager is something that we imported, and if I go to the code of gateway underscore manager, so in the gateway underscore name, we know that we have passed Kong underscore Kong-Ingress-Controller. So from that, it is taking the name of the implementation. So inside the gateways, we have the Kong-Ingress-Controller. So if you see inside the gateways directory, we have Kong-Ingress-Controller class, which is extending this base underscore gateway class, which has this process underscore application abstract method. So if we go into Kong Ingress Controller, it is implementing this process application abstract method. Now going back to the operations operator application, so this handler is received inside this handler, and once this is received, then the process application method is called, in which spec name, namespace, logger, and kwargs is passed. And once it is called, then this particular method is called. And in this method, first of all, it is parsing the global part, where it is taking a global, then base domain, and then environment prefixes. After that, the authentication part is parsed, where it is taking whether the authentication as a whole is enabled or not, and then taking the methods, and from the methods the API token and whether it is enabled or not. So these are the variables which once enabled are going to uh, go into further processing. So if it is enabled, then the these variables like add-on resource reference, resource name, if it is an ingress, then what is the add-on resource name, and then whether the auth plugin is mentioned inside the add-on resource name or not. So if I open the example file for a minute, we can see that in the API token it is enabled. So add-on resource ref has integration name, gateway, and then plugins ingress and the name of the actual plugin. So let me go back. So this auth plugin name contains the actual plugin name. Now it is parsing the common plugins. So if you remember, I said that inside the integrations and gateway part, we can put some common plugins which we know that they should be applied to each and every kind of category of the resource that we define in that part. So this common plugin is for that, but right now we do not have anything. So this common underscore plugins will be blank for now. And then after that, the networking V1 API client is initiated, and then the processing of the microservices part of the component part starts. So for each microservice, we are getting the routes or the number of APIs which are exposed in this route array. And for each route in the routes, we are getting the service name, then the ports, and then the base domain. And if we have anything into the common plugins, then it is copied to current route plugins. But right now it is blank, so it will be blank. And then this is the variable which determines whether API authentication should be enabled for this particular URL or not. So if it is enabled, then this API underscore auth enabled will be true. So once it is true, then after that it checks whether the plugin name is available or not. So we have seen that plugin name is available. Then it checks whether API token is true or not, or API auth enabled is true or not. So we know that both are true. So should apply auth will be true. So if it is true, then the plugin that we have will be added inside the current route plugins. And if it is already there and if should apply auth is false, then we need to actually remove that plugin, because there are also cases when that plugin was earlier enabled but now we want to disable it. So this part covers that. So finally, plugin underscore annotation underscore string has the list of all the plugins that we need to add as annotation inside the ingress resource. And after that, for each of the environment, for each of the prefixes of that environment, we need to generate the ingress resources. So this is the code which does it. So once the ingress is generated, then we need to adopt that particular resource as well, because so basically this adopt part, what it does is, if a custom resource is created with a set of routes, so the ingress resources are created for all of those routes. But if you delete that particular custom resource, then all these ingresses which are created for those routes will also get deleted. So that happens if you call the KOPF adopt for each and every resource that you are creating as part of the execution of this operator. And once this is done, then it is applied to the Kubernetes. So after that, there is some exception handling, and then after that there is some cleanup code. So basically, this is for the case where if there is some environment which was there earlier and now in the update we are removing that environment. So anything which is corresponding to that environment should be cleaned up. So this particular method is doing it, and so this is the method implementation, and this is the implementation of the ingress manifest. So in this particular method, I'd like to highlight this part, that the annotations part is basically uh, taking all the plugins that we have passed when we called this method, and it is putting this konghq.com slash plugins, and after that all the list of all the plugins which we have generated in the process application main method. So with this, once everything is in place, the ingress rule for that particular route is created for the environments which you have mentioned in your YAML file. So once this is done, then we come back here. The result is basically the success or failure. So if it is success, then everything is okay. If it is not, then the temporary error is given by the framework, and this operator implementation is execution completes after that. Okay, so with that, this operator implementation is done. Now we are going to integrate this particular operator within the CNAP Helm chart. So basically for that, what we need to do is we need to create an image for that. So this is the Docker file for it. So inside that, I'm using Python 3.14 as a base image, and I'm creating a app user, because I do not want to execute this application as a root user, because it can create certain infosec issues. And then after that, I am using this user, and then installing all the requirements for the code to execute, and then putting all the Python files inside the image in slash app location, and then finally executing the KOPF with operator application py, and hyphen verbose is basically to generate verbose logs to do the debugging and any troubleshooting. So in this way, this is going to be created. So I will be creating the Docker image, and then I will be importing that to the container D as I did for the test application. And also I'm going to basically add this into the Helm chart of the CNAP so that it gets deployed as part of CNAP. So in the next part, we are going to do the integration of this application.yaml into the chart of our test application, and once it is done, then we are going to do the final integration testing, where we are going to see that with a single boolean flag we can enable or disable a certain NFR functionality. So let us start with the application CR integration with the test application. For that, let me pull up the code. So first of all, the operator code, I have created the Docker image for that and pushed it to container D. And I have also created one dependent chart for the operator applications and added into the chart.yaml of CNAP's Helm chart. And then I have created the new target and upgraded the CNAP with that. And if you see get PO grab operator, now the operator application is running as a pod inside the cluster. And after that, for integration of the application custom resource with the test application, if we go to the test application code, you may see that there is this application.yaml which is added into it, and the ingress.yaml which I added earlier, I have removed it because I am expecting that the operator will create the ingress resources for all the routes which are available into this application.yaml. Now this application.yaml is very much similar to the earlier example YAML. In the specification, I have the gateway with Kong-Ingress-Controller. All the common plugins are commented out. In the global part, the base domain is apiexample.com, and I'm using one environment production without any prefix. And in the authentication part, the API token is enabled with this particular Kong plugin, which is expected to be added as an annotation inside the ingress rules for which the authentication is enabled. And after that, in the components part, I have two microservices or two components. One is API component, another one is users component. In the API component, if you see, I have two routes. One is /API/status, for which the authentication enabled is true, and another one is / for which the auth enabled is true as well. For the user component microservice, I have two routes. One is status API, for which the auth enable is false, and for the / path, again the auth enable is false. So this is updated into the test application. Now let me do the Helm installation. Simple API dot. Okay, let me do install simple API dot. Okay, so the installation is complete. Now if we check get ing, so we can see that these are the 4 ingresses which are created. And if we now go to the postman, let me go to the postman, and then let me try to hit this API. And if I hit it, okay, so I'm getting 401 for the api.example.com. Let me try with API/status. Again 401. Now let me create a new access token. Let me pull a new access token and add it into the authorization header and send it. Okay, so now I'm getting the response, and for the / again I'm getting the response. So remember, the auth enable was true for both of these routes. Now if I disable it and hit it again, I'm getting 401. Now for the users API, we have the auth enabled as false. So if I hit it, I should get the response. So it is users. Okay, so I'm getting the response without the authorization header. Let me check for another status. Okay, fantastic. So I'm getting the responses for the both. Now let me make a change in the YAML file. So what I will do is for the slash API slash status of my api.example.com base domain, I'm setting auth enabled as false, and for my user component for the slash API slash status, I am setting auth enabled as true. So for the user, the auth enable is true, and for the API, the auth enable is false for slash API status. Now let me do a Helm upgrade. Okay, so let me do a KING, and let me do a grep of the annotation, grep OIDC. So for one, the OIDC is not available. If no YAML. So for one ingress resource, the annotation is not there. Let me try with the other one. Okay, so you can see that for the other one it is available. So since we put one false and another one is true, so for this particular ingress, so let me try and fetch the path. Okay, so you can see that for the slash API slash status, the annotation is added. Now let me go back to Postman, and I'm going to hit api.example.com. And so earlier it was giving me 401 without the authorization header. Now it is giving me the response. And if I check for slash, it is giving me 401. If I enable authorization, it will be giving me the response. Now for the user, for slash, the auth enabled is still false. So let me disable the authorization header. So I'm getting the response, but if I hit API status, it is giving me 401 now. And if I enable it, enable the authorization header, I am getting the response. So now with this demonstration, it is concluded that with this complete implementation that we have done in this video, we can achieve the API authorization NFR capability for each and every application, for each and every path that you put into your application if you deploy your application on top of the CNAP platform. So this kind of granularity and this kind of ease in enabling the non-functional requirements without doing any kind of integration within your business logic or your code change, just by integrating a new YAML file and putting some basic configurations into that, you can just enable or disable any of the supported non-functional requirements by CNAP, through CNAP. So I hope you found this complete video useful, and this whole implementation will be available on GitHub. I will be providing the link of the GitHub in the description of this video, and I would invite you to start exploring this platform for your cloud native applications. If you want to collaborate with me in adding new non-functional requirement capabilities, you are welcome to do so. You can reach out to me over the comments over email and through LinkedIn. And if you want to use this tool for you and you want to extend it yourself, Please feel free to fork this from GitHub and do your custom implementations on top of that. Thank you for watching.